Good evening, everybody. Apollo 13. Yes, you probably know the story, but I wanted to recount a slightly personal take on the story. 50 years on, but of course in April last year, other things got in the way. So this is the 51st anniversary of Apollo 13. So of course the Apollo 13 mission started in much the same way as Apollo 8, 10, 11 and 12 with the launch of the Saturn V. Apollo 7 and Apollo 9 were in Earth orbit only, so didn't need a Saturn V. So who were the astronauts on this particular mission? The prime crew were Command Module pilot Ken Mattingly, the commander Jim Lovell, and the Lunar Module pilot Fred Haise. But shortly before the launch, Ken Mattingly was exposed to German measles. Well, actually they were all exposed to German measles, but Ken Mattingly was susceptible and he might have come down during the mission, and therefore it was decided to swap Ken Mattingly for the backup Jack Swigert. So these were the three astronauts that went on Apollo 13. And of course, I'm sure that either you remember the original mission, or perhaps more likely you remember halfway back to the actual 1970 mission. Halfway back was 1995, 25 years ago, yeah, more than 25 years ago, was the film. The heroic efforts of Mission Control to get the three astronauts back from the brink of disaster. It was of course immortalised in the Ron Howard film of 1995. And it is a very good account, and therefore there's no point in me telling you all about the details of the mission, because if you've seen the film, you pretty much know most of it. So if you are going to make a Hollywood film about Apollo 13, you want three heroic astronauts. So who are you going to choose in 1995 to portray a heroic astronaut? The choices were obvious. It was going to be Buzz, Buzz and Buzz. I mean, who else? For those that don't remember, Toy Story came out in the same year as the Apollo 13 film, back in the mid-90s. Okay, maybe that's not the best choice, so they actually came up with a different set of actors. Jack Swigert was played by Kevin Bacon, the commander Jim Lovell was played, of course, by Tom Hanks, and the Lunar Module pilot Fred Haise was played by Bill Paxton. Ken Mattingly was played by Gary Sinise, and it's amazing how many people I talk to, especially young students, who think that Gary Sinise was indeed the astronaut as opposed to him playing Ken Mattingly. But I'm not going to talk about the details of the mission. I'll do a little recap of what was involved in the mission in just a moment. But although you all know that Apollo 13 was immortalised by the film 25 years ago, perhaps you're less aware of the fact that the Apollo 13 mission was immortalised in a slightly different way. Not through Hollywood actors, but through the medium of Lego. Yes, Lego. Isn't that a fantastic little kit there? Spacecraft in the background, Command and Service Module and the Lunar Module. Three astronauts in the middle distance, but notice how much importance they give over to the mission controllers. They, of course, are the real heroes of Apollo 13, the guys that got the three astronauts home. Let's have another look at that. The big board in the background, three mission controllers and the mission control desk with an angle poised lamp, a big red phone so that they can ring up the president, and a couple of manuals on the front there. I guess you can't read them, but one of them says Apollo 13 Emergency Plan. That's the book they open to try and figure out how to get them home. And of course the most key ingredient for any mission controller on the left-hand side of the desk, yep, the cup of coffee. Yeah. If we look at the controllers themselves, we have a flight dynamics officer who seems very happy with himself. In the middle there we have the flight director. I presume that's supposed to be Gene Kranz because he's wearing a white vest, a white waistcoat. The Americans call them vests for some ridiculous reason, but there we go. So there's Krantz. It looks like he's got a fairly austere look and a little bit of a buzz cut. On the right hand side we have an engineer. in common with the flight dynamics officer, appears to have a pocket protector and a slide rule in his pocket, as all engineers do, of course, in the 1960s. And in this case, the engineer looks like he's taking most of the stress from the amount of beads of sweat that are coming off his forehead and a little bit of a grimace. But it's nice that they put in that amount of detail into the mission controllers themselves. What about the astronauts? Well, in the middle there we have Jim Lovell looking fairly happy and obviously in command. On the right we have Lunar Module pilot Fred Hayes with a little bit of a smirk. But what's going on with Swigert? Look at that grimace on the left-hand side. Swigert, the command and service module pilot, this was the guy who was in charge of the command module and technically the service module as well, where the problem occurred. Swigert was the one who threw the switch which caused the spark, which caused the explosion, which caused all of the problems. It wasn't his fault, but he was the one who threw the switch, and perhaps that's why LEGO decided to put that grimace on Swigert's face, just to indicate he wasn't really happy about the whole deal. The actual LEGO of the spacecraft is obviously fairly crude. It's a relatively small scale. So you can see the lunar module at the back there is looking very crude, and then we have the conical section of the command module and the cylindrical section of the service module, which supplies all of the power, all of the water, all of the oxygen to the astronauts sitting in the command module. And for this particular kit, it was envisaged that you could have the pre-explosion version of it, or you could have the post-explosion version where the side of the service module has blown away because of the explosion of an oxygen tank inside there. Any of you looking at that might think that's a rather crude model because, of course, the lunar module in the background there has been made to much higher detail. Is somebody else in the background there? Perhaps they could mute the microphone?
Well, it's where it was last time, probably. I will. I'm just in a little meeting with the Astronomical Society at the moment, so can I do it in about half an hour?
Could you just mute your microphone, please?
I've muted everybody.
Including me? Does that include me?
No, you're okay.
Fine. So the command service and lunar module in the Apollo 13 version, relatively small scale, relatively crude, but of course anybody who wants a better model can go for the Apollo 11 version of the lunar lander, made to a larger scale in a lot more detail, as I know some of you have decided to do. Let's just remind ourselves of some of the abbreviations that I'm using here. So the service module, the cylindrical part that feeds all of the power, the oxygen, the water to the astronauts, who spend most of their time in the command module, the conical section in the middle, and then the lunar module on the right-hand side. Service module is abbreviated, not surprisingly, SM, command module CM, lunar module LM. The lunar module used to be known as the lunar excursion module in the early days, and hence a lot of the time it's referred to as the LEM because its old acronym used to be the LEM. And because the command module spends most of its time coupled up to the service module and command module together are collectively known as the command and service module. No surprise there. But those are the abbreviations I'm using in this talk. So let's just have a look at what was supposed to happen in the original Apollo 13 mission. The Saturn V gets them up into orbit and sends them on the way to the moon. It then takes about 3 days or so for the spacecraft to arrive at the moon. The astronauts, who might spend a lot of their time in the command module, a little bit in the lunar module as well, but when they get to the moon, 2 of the astronauts, the commander and the lunar module pilot, will then move into the lunar module and they'll close the hatch between the 2. Swigert, the command module pilot, will stay in the command module for the entire mission. Once everything has been checked out, they will then decouple the 2, undock the 2, and the lunar module will go down onto the surface. Okay, the astronauts are not hanging onto the leg on the outside. I'm just using this to show where the astronauts are. Having landed, the 2 astronauts will then frolic on the moon for a little while. They were scheduled to have a couple of EVAs, a couple of moonwalks of about 4 hours each. So they were supposed to spend about 8 hours plus rest periods on the surface of the moon. Once they were done, then the ascent stage, the descent stage will stay on the moon, the ascent stage will then return the astronauts back up into orbit to dock with the command module again. So the descent stage of all missions will stay on the surface of the moon. Once they've docked in lunar orbit, the 2 astronauts can come out of the lunar module and return to Schweigat, such that all 3 are then in the command module. Once all 3 are safely in the command module, and again they've closed the docking hatch between the 2, then the lunar module can be jettisoned. Depending on which mission, this one was intended to send the lunar module off. In a case of Apollo 10, the lunar module was sent off in an orbit around the Sun. Other missions, the lunar module was just crashed back into the surface of the moon. Once all the astronauts are back in the command module, they can then return to Earth. Another 3 days. Remember, 3 days to get there, 3 days to get back again. Once the astronauts are approaching the Earth, they don't go into Earth orbit, they just go ploughing into the Earth's atmosphere. Shortly before doing that, the service module would be jettisoned because it's no longer required, before the last and only piece of the spacecraft to return, the command module, would then splash down into the Pacific Ocean. And there you can see kasploosh, there's the water. Okay, that particular graphic makes it look like they're coming down in the Indian Ocean. It's supposed to be the Pacific, but I just liked that picture rather better. Okay, that's what was supposed to happen. What actually happened with Apollo 13? Well, everything went pretty much tickety-boo until about 2 days into the mission, where Schweigat was told to stir the cryotanks, which means they have cryogenic liquids, hydrogen and oxygen, and they get stirred every once in a while to make sure they don't separate out. And there was a problem. As soon as the cryostir was instigated, there was a bang. Houston, we've had a problem. Now, this picture is out of sequence because this wasn't taken until later in the mission, but it just shows you what actually happened. An entire side panel had blown off the service module and a great deal of damage had been done. But of course, they couldn't actually see that because you can't look back to see what's going on. So they deduced what was happening on the basis of telemetry, on the basis of all the instrumentation they had, telling them that they were losing oxygen, they were losing power, etc. What actually happened was one of the fans that was supposed to be stirring the oxygen tank, it had faulty wiring. I'm not going to go into the details of how that happened, but one of the tests done on the ground some months beforehand actually burnt the insulation off this particular fan. And so when this was actually started, this cryostir, it caused a spark which caused the oxygen tank to explode, and it took out the other oxygen tank and it took out the fuel cells as well, and then blew the panel off because of the overpressure of gas that was occurring inside. So they didn't know exactly what was happening other than they were losing power, they were losing oxygen. So they knew that they were in serious trouble. So both in the spacecraft and in mission control, they very quickly realized this is serious, we need to get out of this somehow. What do we do? Everything pointed towards the lunar module was not affected, therefore the 3 astronauts moved from the command module into the lunar module, which still had power, it still had water, etc. So, what are the contingency plans when you have a disaster of this magnitude? Well, they had already thought about it. NASA already had a plan which said if we get to the moon and we land, or we get to the moon and then we have a problem with the command module or the service module that means we have to get home, there were contingency plans for returning with a crippled command or service module for the 3 days it takes to go from the moon to the Earth. In fact, one of the astronauts had actually gone through this contingency plan in great detail. Which astronaut was that? Schweigat. If there's one guy you wanted to have on the mission when things go wrong, it's the guy that did all of the planning for the contingency. But the contingency was how do you get home 3 days from the moon? They're on the way out, and they daren't turn around and try and get back to Earth because they don't know if the main engine works or not, because there was so much damage to the service module. So they decided to go on to the moon, which is still a day away because this happened 2 days into the mission. So they're going to spend a day getting to the moon and then 3 days coming home. It's going to be 4 days rather than the planned 3. So they figured they could probably survive with a crippled mothership for 3 days. But the question is, can they survive for 4 days? So on they went to the moon and of course made no attempt to do anything as stupid as attempting to land. They simply went around the moon and came straight back to Earth again. So they saw the moon from close up, but just for a few minutes, and then they were on their way back to Earth. And of course, most of the story of the film is about how they survived. The fact that for 4 days they had to survive with minimal power, minimal oxygen, minimal water. How can you make all of these resources stretch to 4 days when the systems were simply not designed to do that with the amount of damage that was incurred? So again, I'm not going to go through the details of how they managed to survive, because if you've seen the film, you know, and if you haven't seen the film, go watch it. It's a fantastic film. They must have been delighted to see the Earth getting larger and larger in their window as they approached after what must have been 4 days of very uncomfortable, very cold environment. So 4 uncomfortable days later, they arrive at Earth in a rather unusual configuration, because the lunar module never actually comes back to Earth in a standard mission. So now they're approaching Earth, they're in the lunar module, which remember is the only one that's got full power, and now they say, right, how are we going to actually get back to Earth? We need to get back to Earth in the command module, we need the command module parachutes to open, we need power to make sure the parachutes are not 3 blocks of ice, and that they will unfurl and the various explosive bolts will work correctly. So they had to go back into a very cold command module that hadn't been heated for 4 days and power it up bit by bit. Again, the sequence of how they did that, the role of Ken Mattingly, the command module pilot who got bounced because of German measles, his role in making sure they figured out how to get the power out of the lunar module and into the command module to power it back up after 4 days of shutdown, that is all detailed in the film. So as they're approaching Earth, the lunar module is still supplying power to the command module, and they realise the service module has no future use. So they jettison the service module, and that is the point at which they get their first glimpse, their first photograph of the damage that had occurred just before the service module re-enters the Earth's atmosphere. So at this point they can assess the damage, but of course it's too late. They now have to make sure that everything is powered up in the command module, and they keep the lunar module connected essentially for as long as possible. They are both hurtling towards Earth, they're both going to enter the Earth's atmosphere, but they keep them connected just to keep the amount of power that the lunar module can provide until the last possible moment. And finally they disconnect. Farewell, Aquarius, we thank you. The 3 astronauts then keep their fingers crossed that everything worked, the power up worked, the fact that there was condensation over all of the electronics, they hoped nothing was going to short out, and they splashed down in the Pacific Ocean. Skerploosh. And with great relief for the astronauts, for mission control, for the rest of the world, they survived. Failure is not an option. That phrase was spoken by Ed Harris, the actor who played Gene Kranz, but not by the flight director Gene Kranz himself. When the director of the film approached the various mission controllers, he talked to them to get an idea of the ethos behind mission control. And he asked mission controllers, if you were to have a problem, how do you go about dealing with it? And the mission controllers said, well, if we have a problem, we analyse the problem, we figure out the problem, and we look at all of the possible solutions, all of the possibilities, all of the options, and failure is not one of them. And the director said, great, but way too long for a movie poster. I'm going to shorten it to failure is not an option. And that's how the catchphrase came to be. So Krantz never said that, but Krantz admitted that that does summarise the attitude of mission control. So Krantz used it as the title of his autobiography, which he wrote in, I think it was the year 2000 or something like that. If you haven't read his book, buy it and read it. It's a fantastic book. It so succinctly summarised the attitude of mission control that it's become synonymous with Gene Kranz himself. What happened to the various bits of hardware? Well, the command module, of course, made it safely back to Earth with its 3 occupants, so Odyssey survived. What about the rest of the Apollo hardware? Well, the 3rd stage of the Saturn V rocket, after it had accelerated the command and service module and the lunar module towards the moon, the 3rd stage of the Saturn V was given one last task to perform, and that was, it was programmed to crash into the moon. Previous missions, they had simply taken the 3rd stage, they had made sure it is on a different trajectory to the rest of the spacecraft, and those things are floating around the sun somewhere. But this particular rocket was impacted onto the moon, and the main reason for doing that was because Apollo 12 previously had put seismometers down and left seismometers working on the surface of the moon. So by firing the 3rd stage rocket into the moon at a known time, with a known mass, with a known velocity, they could effectively calibrate their seismometers and see how much of a vibration they obtained, and that then told them roughly if an impact of that size produces a seismometer trace of this much, then they could get an idea of, on different occasions, if a particular meteorite hit, they could get an idea of how big the meteorite was from checking it against the calibration of the rocket. What about Aquarius? After the lunar module was jettisoned, it re-entered the Earth's atmosphere just like the service module did. And it would have disintegrated. We all know that the lunar module is a very fragile craft that's only designed to go down to the surface of the moon. It is certainly not designed to go through the Earth's atmosphere. So of course it would have disintegrated. However, it was very important to NASA to ensure that the re-entry was very carefully controlled, so that any surviving components fell into the deepest trench in the South Pacific. Why were they so concerned? If the lunar module is so fragile, who cares? Why don't they just bring it down anywhere in the ocean? Well, there was one reason. It wasn't what you think might be the densest part of the lunar module, perhaps that's the engine. Well, it wasn't that they were worried about. In particular, they were worried about one component in terms of its safety, and that is plutonium. Here we see a picture of Alan Bean in Apollo 12 removing a plutonium fuel cask from the lunar module to transfer it into that little thing down by his feet. That's called an RTG, a radioisotope thermoelectric generator. Plutonium is radioactive. As it decays, it gets hot. Because it releases heat, you can use its power. So plutonium devices like this RTG, are used to power the surface experiments. It gives quite a lot of power, and it was decided that that would be more compact than having a whole load of solar arrays, for instance. And of course, the surface will be in darkness for part of the time. So an RTG works 24/7, basically. So every lunar module is sent to the moon with a little bit of plutonium, which keeps all of the surface experiments running. But of course the lunar module wasn't supposed to come back to Earth. So with Apollo 13, because the lunar module was going to burn up in the Earth's atmosphere, they tried to make sure it came down such that the plutonium has ended up at the deepest part of the Tonga Trench in the South Pacific. As far as we know, that all worked to plan, and that is where the plutonium is. It's got a half-life of quite a few decades, so it'll be harmless in a little while, but they wanted to keep it as far away from populations as they could. I'm sure a number of you are aware that at the end of the film, Tom Hanks, who plays Jim Lovell, shakes the hand of the ship captain, who is played by none other than Jim Lovell, playing a cameo role to shake his own hand, as it were, at the end of the film. The astronauts apparently weren't kept in the dark, but they mission control did play down just how much of the world was holding their breath waiting for the return of the astronauts. So they were quite surprised to see that there was so much hullabaloo when they got home safely. But I do notice that even though they are only just touching down, as it were, on terra firma, NASA has already got them, apparently on the left-hand side there, has already got them signing publicity photos. I'm not sure who that is on the left-hand side, but they are there signing away so that they can dish out the publicity. Finally, just let me remind you who made what for the purpose of this last element. The command and service modules together were made by one company, and the lunar module was made by a different company. North American Rockwell built the command and service module, and Grumman Aerospace built the lunar module. Remember, the problem occurred in the service module. That's the one that supplies the power, the oxygen, the water to the astronauts. That's the one that's designed to deal with all of these resources. But the lunar module in this context was used as a lifeboat. So in other words, the mission was saved because the Grumman Aerospace spacecraft outperformed itself. It performed beyond specification because it kept the astronauts alive, and it gave them a propulsion system that was compromised in the command and service module. So the engineers at Grumman said to themselves, hey, we saved the mission. We saved North American Rockwell's ass because their spacecraft went bang and we saved them. So the engineers at Grumman Aerospace, once it was all over, once the relief was there, they thought, let's have a bit of fun. The Grumman guys said, we saved the mission, let's send North American Rockwell an invoice. And that's what they did. They sent an invoice via Houston, via the USS Iwo Jima, the ship that picked them up at the end of the day. And Grumman are invoicing North American a bill which includes a towing bill, because the lunar module towed the command and service module all the way to the moon and back. $4 for the first mile, towing fee, $1 for each additional mile. Total $400,004. Also, they charged their batteries using the customer's jump cables. They charged them $4.05 for that. They also charged them a little bit, for instance, the Grumman spacecraft was providing them more oxygen and more water than was designed, so they charged them for a bit of that as well. But they also charged them an accommodation bill. Sleeping accommodation for two. No TV, air conditioned, with radio, with view. That was the accommodation provided. But how much did they charge them for that? Well, nothing, because that was part of the mission. The lunar module was supposed to be accommodation for two astronauts, so there's no point in charging them extra. But although it was designed for two astronauts, during Apollo 13, all three astronauts were in the lunar module. So Grumman charged North American an extra bill, additional guest in room, an additional $8 per night. So there's an extra $32 for having three astronauts rather than two in the accommodation. They were also charged a few other things, and then there was a discount because they're a friendly neighbourhood company, and then no taxes were applied because it was a government contract. But at the end of the day, Grumman sent North American a bill for $312,421.24. This was sent by the engineers at Grumman effectively to the engineers at North American. The boss of Grumman and the boss of North American, I don't think, actually knew anything about it, and they were not best pleased, but I think they took it in the manner intended. Epilogue. Odyssey made it home, and there's Odyssey being put onto the deck of the Iwo Jima. And you can see that it's come through the Earth's atmosphere, and a lot of its outer insulation has been ripped off by its fiery descent through the atmosphere. But before these command modules go into a museum, perhaps you've seen the one in the Science Museum from Apollo 10, but before they put the command module in a museum, they just strip off this outer part of the insulation layer, this sort of gold-looking mylar that is there in a few scraps. There's probably a few square meters still on it. They take this, this off before putting the command module in a museum because they think it looks a little nicer. What do they do with all that mylar? Well, they don't just throw it in a bin. They allow people to buy a little piece of it. If you wish, you can buy a very, very small piece of Odyssey. If you want your own piece of Apollo 13 to put on your bookshelf, you can do that. It's not a lot. I'm not even sure you can see it. I'm putting my finger towards it. It's barely millimeters on a side. But basically, they've taken this thermal insulation, cut it up into tiny pieces, and then sell it through museums. Final slide. 5 or a little over 5 years ago, 6 years ago now, at the 45th anniversary of Apollo 13, they gathered this distinguished lineup of individuals. At the rostrum there, astronaut Charlie Duke. Then we have Jim Lovell, Fred Hayes. Unfortunately, Jack Swigert had died in 1982 and wasn't able to be there. Then we have 3 flight directors. We have Gene Kranz, we have Glyn Lunny, we have Jerry Griffin. And then we have 3 astronauts, Vance Brand, Jack Loosmer, and Joe Kerwin. This was to celebrate the return of the 3 astronauts 45 years later in what has often been described as NASA's finest hour. These people, as far as I know, all of these individuals are still alive. I haven't heard of the deaths of any of these individuals. They weren't able, I guess, to meet to the 50th anniversary because April last year, as we all know, we had other things on our minds. So they are at the moment still alive, but sadly, it won't be too long before we won't be able to see a lineup like that anymore, which is a sad thought. But thank you all for listening.